Hello my dear students, welcome to my video again for Math 30-1 Alberta model answers to assignments with sample questions. In today's video, I am going to start the trigonometry equations. That is another section, trigonometry equation. In my last two videos, I have covered trigonometry functions. The topic for today is trigonometry equations, video number 1. Okay, let's look at the multiple choice question assignment paper, trigonometry equations. Question number 1. Question number 1 asks, what is the value of cot 221 degree? Actually, you cannot do this manually because this is not from the special angle. What you have to do is just put this value into calculator. If you don't have a reciprocal button, we can rearrange like this with the reciprocal identity 1 upon tan 221. Okay, let's do this. Make sure you are putting the calculator into degree mode. Then 221 tan reciprocal. Okay, you get 1.15. Answer is 1.15. Answer number is B. Okay, let's go to question number 2. The question number 2 says the range in radians of the graph y is equal to cosine x. Range. Okay. In order to understand the range of this basic function, actually, you are able to figure out the answer directly. I am just recording this one. This is a basic cosine function. This is a partial graph of the cosine function. This maximum value is positive 1. Minimum value is negative 1. That means the graph lies between y is equal to 1 and the line y is equal to negative 1. The graph lies between these two values, y equal 1 and y equal negative 1. That means you can provide the range like this. Y is between plus 1 and negative 1. This is the way they have expressed the answer. Then you don't have to put the range notation. Okay, answer number is A again. A. Now let's look at the question number 3. Question number 3 that says, what are the exact roots? What are the exact roots of the equation cos x equal half? They have given the domain for the domain x between 0 and 2 pi. Okay, we have did actually multiple number of questions in my previous video under the trigonometry functions also. In order to do that, what's the first step? You have to identify the reference angle. That is cos inverse half. I said time to time, if you see the negative sign here, in order to find the reference angle, you have to consider positive value. But here, this is already positive, nothing to worry about that. X are equal cosine or half. That is from the special triangle 60 degree or radian pi by 3. Let's mark this value. Let's interpret this value in the standard question. Cosine value is positive. Cosine value is half mean positive. Let's recall our cast rule again. CAST. All positive, only sine positive, only tan values positive, only cosine values are positive. That means cosine values are positive in quadrant 1 and quadrant 4. Now, let's mark our reference angle. There should be one solution with this reference angle. There should be another solution with this reference angle. Okay. Now we can read this value in this manner. That means you should read the value as a positive angle because domain has been given as a positive angle. That means you have to read the angle in the anti-clockwise direction. Okay, this is one angle, this is other angle. For the standard position angle, always you have to read the angle from positive x-axis, from initial marks towards the anti-clockwise direction. Okay, this is one angle, this is another angle. Let's write in radian. This is equivalent to pi by 3. This angle is equivalent to pi by 3. Now this angle is right away S equal to pi by 3. For this angle, you have to measure, you have to count this total angle. From positive x-axis counterclockwise means this total angle. 2 pi minus pi by 3. 2 pi minus pi by 3, that is 5 pi by 3. Okay, I got this angle like this. 2 pi minus pi by 3. Okay, this answer, that means answer number is C. Answer number is C. C is the answer number. Okay, now let's look at the next question. Question number 4. Question number 4 says, use a graph to determine which of these values of x not an approximate solution for the equation. Okay, this is the equation. For graphing purpose, you can rearrange this equation at your convenience. Okay. Right side is minus tan squared x. Then I will rearrange like this. Tan squared x equal 7 tan x minus 9. Okay. Now you can take this as y1. You can enter in your graphing calculator as tan squared x as y1 and take y2 as 7 tan x minus 1. Okay. This is a one way of initiating this question. I arrange both sides with the positive coefficient. y1 equal this, y2 equal this. Okay. Then you can use your graphing calculator in order to plot these two equations. I think when you do tan squared x, I will do the rough sketch. I am drawing this manually. When you input this value into graphing calculator, you are getting the press graph y1 as, I think, like this approximate shape, okay? Okay, these are the part of the graph y1, y equal to y1. Then how y equal y2 look like? 7 tan x minus 9. 7 tan x minus 9 in between these two values. This should be approximately like this, okay? Now you have to read this point of intersection. Okay, plot this two graph and read the coordinate of point of intersection. Then actually you should get these three values. If you look at the option A, B, C, D, this is look like option A. Okay, sorry, this look like option B. B is there, C is there, this is look like C. Then there should be minus value for other one. That should be like this. I was in the video number 1, trigonometry equation, there is an interruption. Then however, actually I have done up to question number 4. Now let's start question number 5. What are the root of the equation minus half equal minus 2 by 5 cosecant x? Let's rearrange this equation with the primary trigonometry ratio. That means instead of cosecant x, I would write 1 upon sin x. When you rearrange this, we are getting sin s is equal to 4 upon 5, x reference angle equal sin inverse 4 upon 5, that is 0.8. Okay, I follow these steps. Start up from this equation. Rearrange cosecant x using the reciprocal identity 1 upon sin x. Then right away I have isolated sin x. X is equal to sin inverse 4 by 5, that is 0.8, that is reference angle. Okay, let's calculate this reference angle. When I calculate this, okay, I get 0.93. Let's mark this angle on the quadrant diagram in radian. Okay, be careful, this is in radian. Because the question asks, find the solution in between radian minus pi and plus radian phi. We have to find the solution in between these two values. Okay, that means if you interpret this in a number line, we have to provide the answer in between this interval, negative 5 and positive 5. Start to measure from negative 5 to positive 5. Where is positive 5? We are measuring an angle from positive x-axis. If you measure the angle in counterclockwise, we get 5 here. If you measure the angle clockwise, we get negative 5 here. Okay. Okay, let's mark this angle. This is one reference angle, 0.93. Okay. Actually, I have explained this situation few times in the previous videos. Sin S is 4 by 5. That means sin value is positive. If sin value is positive, there are two locations for terminal arm. First quadrant and second quadrant. Okay, there is another location for terminal arm. Now we should read this angle for these two locations as a standard percent angle. One angle is this. That is this 0.93 itself. Other angle you can read from 0 to 5. Pi minus 0.93. Pi minus 0.93. Let's calculate this value. If you calculate this value in the calculator, I am getting 2.21. Okay. For this range, that is not applicable. If you have another terminal arm like this, we are able to read some minus values. Okay, in this way. That means between minus pi and plus pi, we are getting only these two solutions. SC equal 0.93, SC equal 2.21. Okay, that means the matching answer is answer number A. Answer is option A. Yes, let's continue. Question number 6. Question number 6 says, write the expression minus sine square theta minus cosine square theta plus 1 as a single term. Okay, this is easy. Let's continue this. Let's gather first two terms. If you gather this first two terms, you can take out minus 1. Then inside the bracket you remain with sine square theta plus cos square theta plus 1. From Pythagorean identity, we know that sine square theta plus cos square theta is equal to 1. That means the answer will become minus, this is 1, this is plus 1. The answer is minus 1 plus 1 is 0. Okay, that means option number is, answer is B. Answer is B. Then let's work on next question. Question number 7. Write the expression. Write the expression cot square theta plus tan square theta minus cosecant square theta plus 2 as a single item. Okay. Let's try to simplify this as much as possible. How do you do this? Okay. That is one way of doing. Okay. I wrote these two terms as it is. I wrote these plus 3 terms as it is. But I will use a little trick about that. 2. Instead of 2, I would write 1 plus 1. Why I wrote 1 plus 1? Why don't I write half plus 3/4, half plus 3 by 2? Any other thing? 3 minus 2. Because actually from Pythagorean identities, we know 1 plus tan square theta will become secant square theta. Then that is one thing. Also 1 plus cot square theta, cosine square theta. Let's gather these two terms, okay? First this one and this one. First term and last term. 1 plus cot square theta. Then let's gather these terms. Second term from the left, second term from the right. 1 plus tan square theta minus cosecant square theta. Now what's the answer? From Pythagorean identity we know 1 plus cot square theta equal cosecant square theta. 1 plus tan square theta is equal secant square theta minus cosecant square theta. Now these two terms would cancel. You remain with only secant square theta. Okay, that means answer number D. Okay, that means we have already discussed under trigonometry equation assignment question number 1 to 7 under video number 1. But on the way of doing with this video, there was a little interruption. Okay, sorry about that. Then I will continue rest of the question in my next video. Thank you very much.